This is Ali Kabeel, and today we will be seeing breaking the giants with application-level denial of service attacks. So let's start by who am I? I'm a computer science and engineering student at the German University in Cairo. I have been a bug hunter and a security researcher since 2014. My main research interests revolve around privacy with application security, network security, and logical vulnerabilities in specific. I have been a speaker at Besides Las Vegas 2021 and IEEE LCN 2021 as well. You can find me on social media at LogicBreaker on Twitter and at Kabeel on LinkedIn. So let's start by some motivation, and let's break our title into two parts. So our title is Breaking the Giants with Application-Level Denial of Service Attacks. So the first part is Breaking the Giants. What do we mean by the giants here? So the giants are gigantic companies like Snapchat, Facebook, Google, and so on that have huge infrastructure and are multi-billion-dollar companies in general. The other part is application-level denial of service attack. And because this word is a bit complicated, we will start by giving some background information about what is a denial of service attack in general. Before we define denial of service attacks, just to make sure that everybody here understands what the CIA triad is. So a CIA triad is like the golden standard defined by information security experts. It will define a system to be secure in general. So it consists of three main parts. The first of them is confidentiality. And confidentiality refers to the fact that whenever an information is considered a secret or is considered to be not public information in general, it should stay within the system. That means that this information should not be leaked anyway to malicious adversaries or even to third parties that are not intended to have this information. When the information only stays within the system and is only accessed by the authorized personnel, we can say that this information is confidential or the confidentiality is not affected. The other part, which is the I in the CIA, which is the integrity, refers to the data integrity, which means that the data is not altered, is not tampered with, nobody changes the data. The data is the real data, the authentic data in the system. So for instance, if you have a Facebook account and you logged in and you see that your name is changed, for instance, this may say that the integrity of the data has been violated. You haven't changed your name. This is not the data you stored. The integrity has been violated. But if everything is just like what you did, nobody altered or changed the data, we say that the data integrity is high or that the system is integral. The last part, which is our target here, is the availability. And the availability of the system is the ability of the system to serve its users, to serve its customers, to be usable. Imagine having the most confidential system in the world with the best integrity ever, but the system is not usable. Nobody can access the system. It has no availability. The system is completely useless. And that is the target of denial of service attacks. So denial of service attacks are a class of attacks that aim to disrupt the availability of the service. It aims to make the service not available to its customers, to its users, to its benign users. In the past, this was done using brute force. So adversaries just launched what we call high volume denial of service attacks. Those are attacks in which the adversary just sends billions of requests direct to the server, aiming to make the server unavailable to its legit or benign users. The idea here is any server has some kind of capacity. If you consumed all this capacity with fake or bogus requests, the server cannot withstand or cannot handle further requests. So what they did is that usually adversaries distributed malware or something that allowed them to get control of a huge computational power or a huge number of PCs or a huge number of computational devices in general, and then use those devices to launch denial of service attacks, or what we call distributed denial of service, because it's launched from both nets and a huge network of connected computers launching the attack at one time, not just from a single machine. So this was very effective, and it has proven to cost millions and millions to companies. But this is starting to change. This attack type is starting to change. And there are two main reasons here. The first reason is that it requires a huge computational power. The attacker needs to have access to a huge computational power to inflict enough damage. Even with this amount of computational power, it's really unlikely that you can target something like Facebook or like Google or like those gigantic companies with huge data centers. It's really unlikely that you can target them using conventional denial of service attacks that aim to just jam the traffic so that benign users cannot use it. They have huge computational capacity that you won't be able to withstand. The other reason is the advances in intrusion detection systems and in cloud solutions like Cloudflare that now aims to mitigate those denial of service attacks are becoming very popular and are becoming very smart using machine learning algorithms and AI algorithms and so on. The idea here is that heavy load or high volume denial of service attacks cause a huge increase in the number of incoming requests to the service or the server, which raises a lot of alarms. So any intrusion detection system will know we are under a denial of service attack. Imagine that you usually handle 10 requests. Now you are facing like 100 requests without any good reasoning for that. So it's definitely a denial of service attack in that case. And then we can work on the mitigation faster because we know that attack exists. So before we move on and see how this changed, let's take a few examples regarding high volume attacks. The first of which is the SYN flood attack. So the SYN flood attack exploits a vulnerability that exists in the TCP protocol. So the TCP, to initiate a connection with the server, you do what we call the TCP three-way handshake. So the first thing, the user will send a SYN packet to the server, and then the server will reply with a SYN ACK packet. Finally, the user should reply with an ACK packet to complete the connection. But what a malicious attack would do would be the following. The attacker will send the SYN packet, and then the server will reply with a SYN ACK packet. But the attacker will never reply with an acknowledgement packet. The idea is any server has a certain number of connections it can withstand. For instance, server can withstand 10,000 connections at a time. If the 10,001 connection attempted to connect, it won't be able to do so because the capacity of the server is exceeded. So what we are doing here is that we are initiating connection with the server. We are not completing the connection, so the server is waiting for us to complete the connection. We are consuming that, but we are never connecting. So we are virtually consuming those, and usually the timeout period of TCP handshakes are a bit large. So with enough computational capacity, we can just fill the whole connection pool, and then benign users will not be able to connect to the service or to the system. Another famous example is the ping flood attack, and the ping flood just utilizes what we call the ICMP protocol. And there are two parts to this attack. The first of which, the attacker will just send ping packets, the very famous ping packets, to the target system. And this actually consumes two things. The first of which is the incoming bandwidth to the system. Whenever the ping packets are sent to the system, they consume the incoming bandwidth because we have a huge amount of ping packets. So incoming user requests are very much delayed because of that. But there is another part to it, which is the outbound request. Because whenever a server receives a ping packet, it will have to reply with what we call an echo ping packet. This will result in eventually the server not being able to serve benign users because its incoming request is being jammed with ping packets, and its outbound request or its outbound bandwidth is being jammed with the echo ping packet generated as a reply, which means that the benign users will not be able to utilize it. So let's go into a bit of details of what is application level denial of service attack from a theoretical point of view. So from a theoretical point of view, according to Wast and Forsberger, application level denial of service attack is a class of denial of service attacks that aim to target the application layer of the system. The application layer here refers to whichever vulnerabilities that can be found in the application layer or the application itself that causes denial of service attack. It's not related to the network layer like the high volume attacks we just explained. It's related to the application and the application level vulnerabilities. And the very famous example of that is what we call the resource locking on failure. What do we mean by that? So imagine that you are using a server to do some computations, and then, for instance, any failure happened because you divided by 0, for instance. So what happened is the system will go into a failure state, and ideally the system will release all its resources used for the computations you were just doing so that other users can do it. But some systems mistakenly will just lock the resources on failure. So once we fall into a failure, this part of the system or this part of the server cannot be utilized by other users and cannot be utilized by you. So if you are a malicious person, you can think, okay, what if we caused a huge number of failures so that all the server capabilities will be locked, or all the server resources will be locked on multiple failures, and the benign users will not have any part of the server left to do their computations and so on. So this is a very famous attack in which the application level is the problem here, because the application level should release the resources. So Moving further, we have here a case study on what we call the second-order denial-of-service attacks. So before we talk about second-order denial-of-service attacks, let's just remember what is a second-order cross-site scripting is. So the second-order cross-site scripting is a class of cross-site scripting vulnerabilities where the payload of the cross-site scripting is stored in the database and then is later rendered somewhere in the application, and boom, the payload fires. Second-order denial-of-service attacks are no different. The amount of data that will cause, or the thing that will cause the denial-of-service attack, is stored in the database. And that's why we call it second order, because the data is stored in the database, and later when we do some action, it triggers the denial-of-service attack. So there are two factors for this attack. The first of all is the missing late limit on data creation. Imagine having something like a paste bin, and then you found out that there is no limit to creating number of pastes. So you just created a bot and created 10 million pastes, for instance. Okay, so now the first part of this attack is that you are jamming the server or the database with unneeded data, with garbage data, because nobody is utilizing it. But this is not the worst part of it. The worst part is then you go to your account and then attempt to view your pastes. What happens is the server will go to the database, ask him, what is the paste of this user? And it will tell you, okay, we have 10 million pastes. And then the server will attempt to retrieve them. If the server doesn't put an upper bound, like for instance, I will just retrieve the first 100 pastes, what will happen is that the server will be hugely consumed to retrieve 10 million pastes. Imagine this number being retrieved from a database. The time is huge. And as the number increases, the time increases. That's what we mean by linear time. As the number of data or the size of data will increase, the operation will cost more time, eventually rendering the system in a denial-of-service state, because the service will be very busy doing this bogus operation of getting back our data. So let's see some case studies. One of them focused on second-order denial-of-service attacks. Both are on Snapchat. So the first is a zero-click second-order denial-of-service attack on Snapchat developer portal, and the second will be fooling Snapchat API to achieve what we call a targeted denial-of-service attack. So let's dig deeper. So Snapchat has what we call a developer portal, in which you have organizations, and then you can invite developers. Actually, you can add developers without any invitations, which is in itself a problem. You just type the developer email, and they are added automatically to your organization. The idea here is you can create any number of applications. So there is something that's called applications inside the organization. You can create any number. So I thought, okay, what about creating 10,000 applications? Once I created 10,000 applications, my account got blocked. I couldn't access the account. Whenever I accessed, I got like 500 internal server error and so on. So I thought, okay, now I got a self-denial-of-service attack. Congratulations. What can I do with that? And then I thought, okay, but I can add others to my organization. Now the thing is, you create a huge amount of applications. Anybody in your organization who will attempt to log into their account, the server will automatically try to retrieve this 10,000 application, so their account will not be used. It's not an attack on your developers, it's an attack on any developers. Just by knowing their mail, even if they are part of other organizations, you just add them. Whenever they log in, automatically this data will be fetched. A timeout will occur because Snapchat didn't allow you to fetch 10,000 records. So the 10,000 records will take, for example, 3 minutes. They only time out after 15 seconds. So they will give you internal server error because a timeout will occur. So whenever a developer tries to log into their account, they will not be able to do so, which means that they are denied from accessing the server and they are logged out of their account, or their account are not usable anymore. Let's move further into the API fooling part. And also Snapchat had what we call a business account. The business account is linked with the developer account. So whenever somebody is added as a developer, they are added automatically as a part of the business. So the idea here is that the business account was some kind clever. They had invitations, so people will not be added automatically. But just keep in mind that whenever you add somebody to the developer's account, they're automatically added to your business account. This information will be used later. Okay, so you just send somebody invitation, and then I intercepted the traffic using proxy and found out that the request after sending the invitation is assigning a role to the person. So the person is assigned as a developer and an organization admin and so on. So I thought, what will happen if somebody is a part of an organization and they have no role in it? So I just dropped the request. Now I sent an invitation. That person has no role. And then I went to my test account and just accepted the invitation. What happened is, boom, the account just blew away. It got locked. What happened here? The API looked at it and say, Are you a part of organization X? And the answer was yes, I'm a part of organization X. Do you have any roles there? And the answer is no. But how? You are a part of an organization and you have no roles. Something might be wrong. So I will just close the whole account. This is not the normal API behavior, but it was a bug in the API itself. And instead of just denying the user from accessing my organization, it denied him from accessing any organization. Whenever you just log in, okay, you are unauthorized, but I haven't done anything, but you are unauthorized. Why? Because we manipulated the API somehow to target people. But then you might say, okay, the user has to accept an invitation. This is not a zero-click attack. But I will tell you, I just said that whenever you add somebody to the developer account, they are added to the business account. So you just go into the developer account that has no verification, no invitations, add their email, they are added automatically with no role, and boom, whenever they access their business account, they are completely denied from accessing it, which is an application level vulnerability because it's an API problem. The API here denied the user from accessing his account. And it's actually the kind of denial of service attack that you might expect to find in a huge company like Snapchat, because there is no chance that you will have a computational power that can actually bring the amount of service that Snapchat has down. So usually this is the kind of vulnerability you should focus on. So sharing some final thoughts about how to find an exploit level, application level denial of service vulnerabilities. Usually I would suggest that you look at previous reports on something like HackerOne and so on. Dig deeper into an application, understand it further, because usually they are logical vulnerabilities that arise to business denial of service attacks. Focus on things like second order denial of service attacks and other known application level, because they usually occur now and then. So just like you are looking for second order cross-site scripting, search for second order denial of service attacks the same way. So about my future work and what's next, I'm currently looking into attacks regarding denial of service from microservices, which is an emerging architecture. I'm trying to do some emulation and simulation to automate those attacks and to understand their behavior and so on. So this is what I'm doing right now. Finally, I would like to thank Chembox. He was my mentor at my very first talk. Without him, I wouldn't be here today. I would also like to thank Symbian, Moha, at Zigo, and at Matrix. Those people mentored me at some part in my life, and I'm still learning from them, so I would urge you to follow them on Twitter. They usually share very useful stuff regarding security that you will definitely benefit from. Finally, I would like to thank you all for attending, and I would be happy to address any question that you might have. Thank you, everybody.